welcome back, boys and girls. It's your main math man, Mr. Shang, coming to you live from Alameda International High School. And in this video, working on some review problems, making sure you can see how these are done. So on the first one, it's saying find the arc JN. So you're looking for this outside amount, and we can say, hey, I can use the central angle. Again, I can use that central angle that it gives of 119 because I know that the central angle is going to be equal to the arc that it goes with. So I'm going to say that arc JN is going to be equal to 119 degrees. So again, that first one, no calculation needed. Just make sure you're knowing central angle is equal to that associated arc. However, in the second one, make sure you're saying, okay, I know this is going to be an inscribed angle because our vertex is on the outside of that circle, so it's going to be on around that circumference of that circle. And so we can say, all right, our inscribed angle, let's have angle FEG is an inscribed angle, and we know it's going to be that's equal to half of that arc FG. So if we're able to find FG, then we can find our arc that we're looking for. And so what I can do is this, I can say, okay, a full circle is going to be 360. And what I can do is to find our arc FG, I can subtract away these two amounts. So I do 115 and I subtract 153. And I can say that's going to be 93 or 92. There it is, 92 degrees. However, be careful because you have to take half of it to have that inscribed angle. So we're saying this is that arc FG, and we're looking for the measure of angle FEG. So we take 92 divided by 2, which is equal to 46 degrees. We're going to say that's going to be the measure of angle FEG. On that next one, working with those wonderful pyramids, it says find the surface area and volume of that pyramid. So it gives you a couple dimensions first, and so we can say this is going to be our vertical height. So our vertical height is going to be h, which is 12. And then it has that side length of 11 on both sides, so that way we know it's a square base. Make sure you trace the base, redraw the base, and so I can say, hey, since each of these side lengths are 11, again, make sure you can find the area of the base, which is that big B, so that is just going to be 11 times 11, which is 121. And then to find the perimeter of the base, you can add up all the sides, so I'm going to say that's going to be 44. Make sure you are finding that slant height next. So I need to find this height going along the outside. And so I know that, hey, if I can redraw what I'm saying, I would have a right triangle. And I have to be careful because I know that my vertical height h is 12. So I'm going to say that this side length is 12. However, notice how it goes halfway through the base. So I'm going to say it's going to be 5.5 for my other leg of this right triangle. And we're going to say that hypotenuse is going to be L, our slant height. So that's what we need to solve for. So we're going to do Pythagorean theorem. So we're going to say 5.5 squared plus 12 squared is going to be equal to L squared. Make sure you calculate carefully. So I'm going to say, all right, I have 5.5 squared. So I have 30.25. 12 squared is 144, and that's equal to L squared. Again, make sure you add those two together. So this is going to be 174.25 is equal to L squared. Last step, make sure you take the square root of both sides. So I'm going to say, all right, take the square root, so second, and then exponent. So I have 174.25. All right, so you should end up with your slant height L is going to be about 13.2. And this is helpful because, again, this is going to be our slant height. So you need to be able to use that for your formulas. So I can say for my surface area, so I'm going to say my surface area is going to be equal to the slant height L times the perimeter of the base P divided by 2 plus the area of the base, which is that big B. You can make sure you plug in those values carefully, so substitute in your values for your variables. So I'm going to say, all right, I have surface area is going to be equal to, I have 13.2 times 44, all divided by 2, plus the area of the base, which is that 121. Again, make sure you type that in all as one line, so I have 13.2 times 44 divided by 2, and then plus I have 121. So I'm going to say my surface area is going to be equal to, and I have 411.4, and then I'm going to say it's going to be centimeters squared. So make sure you have, for surface area, it's the second power. However, for volume, real simple. Still the area of the base times the height divided by 3. So I can say I have the area of the base, which is 121, times the vertical height, which is 12, all divided by 3. So I have 121 times 12 divided by 3. I'm going to have that my volume for this pyramid is going to be 484 centimeters cubed. So again, make sure you're using those values for yourself. Again, make sure you use the formulas correctly. Use the Pythagorean theorem to find your slant height and plug in your values. Underneath of that, it has for our cone. Again, find the surface area and volume of cone. Real similar setup. However, if you notice, when you trace that base and redraw it, I'm going to have a circular base. So that means this. I have our radius is 2, and our vertical height, h, is 10. So same kind of setup. I'm going to have to find my slant height using that Pythagorean theorem. But what I can do is I can find that area of the base first. I'm going to say, all right, big B, that's the same as pi times the radius squared, since that's the area of a circle. So I'm going to say, all right, I have pi times the radius squared. So it's going to be about 12.56. So it's about 12.56. So now I can say, all right, I can find my slant height L. So use your right triangle. I can say, all right, vertical height is 10, and my base, or my other leg of this right triangle, is going to be 2, since it already has that it's halfway across for our radius. And that other side, our hypotenuse, is going to be L. So same setup, I have to have 10 squared plus 2 squared is equal to L squared. So that's going to be 100 plus 4 equals L squared. And so I'm going to have 104 is L squared. Take the square root of both sides to get your answer. So I'm going to say L is going to be about, so I have L is going to be about, let me double check on that value, second square root, and then 104, so yeah, 10.19. All right. So now make sure you're using this formula for yourself. So that's going to be the surface area is going to be the area of that base, which is that big B, plus pi times the radius times that slant height, or yeah, that slant height L. So make sure you can say, plug in those values. So I have surface area is going to be equal to, it's going to be that 12.56 plus pi times the radius, which is 2, times the slant height, which is that 10.19. So make sure you use those values like so. So I can say, all right, I have the area of the base. I'm going to use those arrow keys to go up, highlight on your calculator those values. Make sure you do plus, and then I have pi times the radius times our slant height, which is L. So notice how I can use those arrow keys to highlight and enter in those values, so that way it's more accurate of an answer. So I'm going to say I have surface area is equal to, and I have 76.64, and I'm going to say centimeters squared. For your volume, it's the same formula as your pyramid, but it's going to be area of the base times the height divided by 3. So notice how the area of your base is going to be different, since those two shapes are going to be different. So I'm going to have like this. I have 12.56 times our height, which is 10, divided by 3. So I'm going to have, let's do, we have pi times the radius squared times 10 divided by 3. So we're going to say our volume for this is going to be 41.88, and I can say centimeters cubed since we're talking about volume. So again, make sure you're seeing the difference between the two values. You're saying, again, for surface area, I have units squared or square units, and then I have for volume, I have cubic units, meaning units to the third power. On the back, make sure you can do those conversions. And so I'm going to say like this. Again, set it up, have your what you're starting with. So I have 90 centimeters, and I need to convert to inches. So you can use that conversion that I gave you. So you have for every 1 inch, I have 2.54 centimeters. So when you're working with this table, make sure that you're saying, okay, I need to make sure my units cancel out on the diagonal. So I need to make sure that, okay, centimeters are canceled out, and then I can multiply across the numerators, multiply across the denominators, and I'll be good. So in your calculator, you just have 90 divided by 2.54. And so you're going to say this is going to be equal to, and I have 35.43, and then inches. So that one's super simple, but make sure you see how it's set up. Again, across the diagonal is where you cancel out your units. However, on each column is where you have your conversion. So I have for every 1 inch, it's 2.54 centimeters. Underneath of that, a little bit trickier one, but same kind of setup. So I'm gonna say, okay, I'm starting with 60 kilometers for every 1 hour. So again, it gives you the units to start with, and now I can say, okay, I can work with either time or distance first. Either way, it's fine, but make sure you're, working on the diagonal. So if I need to go from kilometers per hour to feet per second, I need to make sure I do both conversions. So I'm going to say this. I can say, okay, I have kilometers, so I need to get rid of them. So for every 1 kilometer, I have 1,000 meters. And now I still need to convert to feet. So I can say, all right, I have for every 30.48 meters, I have 1 foot. So make sure you're saying, again, I'm working on the diagonals for my units, but I'm using the columns for my conversions. So now that I'm in feet, I can convert my time. So I need to switch from hours to seconds. So I need to have, okay, in the numerator, I need to go for every 1 hour, I have 60 minutes. And then for every 1 minute, I have 60 seconds. So again, make sure you're seeing how these are set up. Again, be able to multiply across your numerators, multiply across your denominators, and then write your answer after you divide. So I'm going to do it like this. I have 60 times 1,000, and then I can do times 1 times 1 times 1, but it's not going to change my answer. But I have this. All right, so I have 60,000 divided by, and then multiply your denominators together. So everything in the denominator is what I need to multiply together. So 30.48 times 60 times 60. So make sure, seeing it like that. Okay, I knew I was forgetting something there. So let's have, I had for every, there we go. So this should be, let me throw in another conversion, because this is centimeters. It's 30.48 centimeters. That makes more sense. So I had for every 1 meter, there's 100 centimeters. There we go. That was the last part I forgot. So I need to take this value times 100. Okay. So I'm going to say, all right, I have 6, and then 1, 2, 3, 4, 5, 6, all divided by 1, 0, 9, 7, 2, 8. There we go. So let's try this now. So this divided by our denominator. There we go. It's a better answer there. So we're going to say, we're going to have these two divided. It's going to be 54.68. I'm going to say feet per second. So again, be careful when you're setting these up. Again, make sure your units are canceling out along the diagonal. So I add kilometers to kilometers, meters cancel out, centimeters, centimeters. I have also time cancels out, so hour to hour, minute, minute, and so I'm left with the only set of units being feet per second. Again, make sure you can see how these work, and always super slam that subscribe button.